Welcome back. In the last few videos, we have discussed about generation part. From now onwards, we are going to discuss about transmission part of electrical power systems. Okay, so how the transmission lines or network got evolved over a period of time in Indian scenario. Let's move on. So, first of all, why should we require a transmission network? This was answered earlier videos also. It is mainly because of uneven distribution of power resources. We have huge amount of hydel power resources available in northern and northeastern regions and coal in eastern regions. So instead of since the transportation of coal is costlier than transporting power, we need to install the generating stations only at the resources places where resources are available. Okay, and then we need to transmit the power, the bulk amount of powers over these transmission lines. Okay, that is the purpose of constructing these transmission lines. Okay, so the scenario is there are surplus amount of energy there in eastern region, and obviously there is a shortage in the southern other regions. Okay, so by the end of 11th plan, the country has total inter-regional transmission capacity of about 28,000 megawatts. Okay, we can able to transfer 28,000 megawatts or 28 gigawatts of power from one point to the point. And here in 12th plan, it has been enhanced to 65 gigawatts in the 12th plan. Okay, so this is the strength of our transmission, inter-regional transmission links. So if you look at the evolution of this power system in India, pre-independence, it is small isolated systems. We used to have small capacity generators, which are used to cater the needs of the local industry. In those days, there is no need of transmission networks. Okay, small distribution networks are enough to transmit the power that is generated locally. Okay, and prior to the 60s, generation and transmission are maintained by state electricity boards. Okay, even what are the small transmission lines that we used to have, they are maintained by state electricity boards. And during 60s, there is limited interconnection between neighboring states. Okay, so even during the 60s, there is no regional interlinks. Only we used to have interlinks between the states. Okay, very few states. Okay, and then in 70s, there is an emergence of central sector generation. Okay, like these corporations like NTPC and NHPC and nuclear corporations were established. Then the scenario got changed. Planning of generation and transmission on the regional basis. Okay, so from that point of time, then we are looking at the regional level. Okay, from the state networks, now we are moving on to the regional networks, where a few states were combined and formed as a region. Okay, and when it comes to the late 80s, there is an integrated grid operation through 400 kV AC systems. Okay, so then the birth of national grids were thought in late 80s, and then in late 90s there was a development happened where there are asynchronous interregional links on long distance with long distance HVDC links and back-to-back stations. Okay, so because the southern region used to have a lot of problems, and in order to avoid the problems that are created in one region with the other regions, we used to have asynchronous inter-regional links, okay, in order to avoid the disturbances in one region on the other regions. Okay. So initially we used to have isolated systems that are developed in and around industrial and urban areas only. They are going to cater only those industries and urban area consumers only. And later, when the Central Electricity Authority was established under the Electricity Act 1948 for the coordinated development of power sector, then we have a policy for the entire nation under this Central Electricity Authority, and it has also provided the information for the state electricity boards in the states, okay, for the formation of state electricity board. Okay. And then the systems around the urban and industrial areas grew into full-fledged state grids. Okay, initially we used to have the small industrial groups or small local generating stations, and they have drawn up to state level grids. Okay, and the country has demarcated into later when in 80s when regional level grids were developed. The entire country was demarcated into 5 regions: northern region, southern region, eastern region, western region, and northeastern region. Okay, so total we have the entire country was divided into 5 regional grids, and all the regional grids are independently interconnected. Okay, so we come under southern grid. Okay, southern region grid. So regional electricity boards were established in each of the regions for facilitating integrated operation of the states. And interstate lines were planned which were treated as centrally sponsored schemes. Okay, so central government taken initiative and started constructing interstate transmission lines to uh, cater the needs across the states. Okay. So then in 1975, center sector generation utilities were created. It's NTPC and NHPC. Okay. So benefits of this to be shared. What are the generating stations that are developed by NTPC, or what are the transmission lines that are constructed by the this central sector generation utilities? They are shared with the states of the region. Okay, wherever the generating unit stations or transmission lines are constructed, the benefits are also given to the state governments. It's not completely taken by the central government. Okay, part of the generation is given to the state governments also. Okay, for example, the NTPC Ramagundam, if you have generation, part of that must be given to the local state, that is Telangana. Okay, in that way, the local states are also got benefited by the generating stations that are established by the central governments. Okay, and then construction of associated transmission system for evacuation of power as well as the delivery of power to the constituent states also entrusted to these corporations. Okay. So these are responsible for the generation as well as transmission of the power that is generated across the states. Okay. So focus of planning and development of the transmission system shifted from the state grid to the regional grid in those days. Okay, and by the end of 1980s, strong regional networks came into existence. Okay, so these are the regional grids that are talking about. That I'm talking about. So we have northern region whose regional load dispatch center was established at New Delhi, located in New Delhi. And if you look at the western region load dispatch center, it is located in Mumbai. And all these states, Madhya Pradesh, Maharashtra, Gujarat, come under this western region. And when it comes to the southern region, Telangana, Andhra, Karnataka, Goa, this Kerala and Tamil Nadu comes under southern region. And then we have eastern region, whose headquarters regional load dispatch center was located in Kolkata. And we have northeastern region, whose regional load dispatch center was located in Shillong. In this way, these 5 regional load dispatch centers and 5 regional grids are used to work independently in the initial stages. Okay. So what are the regional grid that is there in the southern region that is responsible to cater the needs of all these 6 states, okay, located in southern region. Okay. So in that way, the initial electricity map was divided into 5 regional grids. Later, so this is how you can see the hierarchy of the data that is transferred from the substation level to the national load dispatch center. Okay. Just if you look at the substation level, we will have RTUs. In the coming days, we are replacing them with phasor measurement units called as PMUs in short. So at the substation level, we have these devices. Almost we have some 1160 devices. The substation level, which are continuously sending data to the district level load dispatch centers at various districts. So then from there, the We will call those dispatch centers as sub-load dispatch centers, and the data is transferred from that to the state load dispatch centers, okay, which are located at the headquarters of the states. And then from these state load dispatch centers, the data will be transferred to the 5 regional load dispatch centers located at various parts of the country. And then the entire data will be monitored from the national level load dispatch centers. This is what I have called as brain for the entire electric national grid in India. Okay, so this is how the data flow goes on to the national grid, as well as the control actions. If the necessary control actions to be taken, those control actions can be taken at different levels: substation level, sub-load dispatch center level, and state load dispatch center level, and as well as regional load dispatch center level and national load dispatch center level. Okay, this is the hierarchy of the entire power system. And in the next video, we are going to discuss about how these regional load dispatch centers or regional grids are converted into a national grid. Okay, that's what we are going to discuss in the next video. Thank you.